Hello friends, in today's question, a block of mass m has a circular cut with a frictionless surface as shown figure. The block rests horizontal frictionless surface of a fixed table. Initially, the right edge of the block is at x equals 0 in a coordinate system fixed on the table. A point mass m is released from rest on the topmost point of the path as is shown, and it slides down. When the mass loses contact with block, its position is x and the velocity is v. At what instant which of the following options are correct? So this is a mass and it is a slope. A piece is cut and small mass m is placed on it, and the initial coordinate system in xy is given, right side is given as x equals 0, and we are going to find out which of the option is correct the moment when this ball leaves from this point here. So let us draw this figure once again. So this is the initial coordinate system, x equals 0, and we have a ball here, okay. And it says that when the ball reaches the bottom, this block, that is capital M and this is small m, it has moved by a distance of x. So let's draw it again, and we assume that this is the new coordinate system of the block. Now the ball is here. Let us suppose it is velocity v1, this velocity is v2, and the distance moved by is x. So this is x equals 0 and this is x is equal to x. So this is the coordinate system, and we have a mass is capital M and this mass is small m. So in this case we can clearly see that there is no any external force on the blocks, so we can use conservation of energy and conservation of momentum. Okay, and later on we are also going to use center of mass. You can say in the absence of external force, energy conservation and momentum conservation. So let us first use energy conservation. So initial potential energy is, because this height is given as r, so we can say initial potential energy will be equal to the final kinetic energy of small m plus final kinetic energy of capital M. Now this block M is lying on the surface, so its initial potential energy will be equal to 0. So you can say the initial potential energy will be only of this small m, which will be equal to mg r is equal to half m let us suppose this is v1 and this is v2. Okay, much more easier. Half m v1 square plus half m v2 square. Now we try to solve this a little bit further. We divide and multiply this equation, this part particular, by capital M. So we can say mgr is equal to half, this will be coming as m square, so we are going to write it whole square divided by m plus half m v2 square. Question 1. Now we write for the conservation of momentum. Momentum conservation, we can say mv1 is equal to mv2. Now we use mv1 from second equation and substitute in a first equation. So from using equation 2 in equation 1, we get mgr is equal to half, and this is m v2 whole square divided by capital M plus half m v2 square. And we can further solve it. We get mgr is equal to half, this will be m square v square m plus half m v2 square. Now this m cancels throughout, so we are left with gr is equal to, we can take half and v2 square common, this will be half, and this will be m upon m plus 1 and v2 square. So we get this as equal to half m plus capital M divided by m v2 square into gr. So we can write that the v2 square is equal to 2, this will be gmr divided by m plus capital M, but in the question it is in the different format, so let us change it to gr, and this will be 1 plus m plus capital M. So we get v2 is equal to square root of 2gr divided by 1 plus m divided by capital M. So this is the velocity of point mass. Okay, so option number A is correct one. This is velocity of point mass m. In this case it is given as v, I have written by v2, so we can say this is v is equal to v2. On the second part, we are also going to find out what will be the other things, and from here you can say that we are going to use now center of mass. Okay, and And under this condition, you can say so once again, in the absence of external force, in the absence of external force, the center of mass will be equal to 0. Okay. And therefore we can write the equation that m plus capital M, it is moved by a distance of x, and our second, that is the distance is r, and that is mr is equal to 0. So we solve it, and from here we can say that x is equal to minus mr divided by m plus capital M. So we get that the x component or displacement of center of mass of block is minus m upon r. So option B is correct. So this is the displacement of x component of displacement of center of mass of block capital M. Okay, so please bear in mind that this is the x component. Okay, so this is option B is correct, and we have option A is also correct. This completes the question. Thank you. So in triangle, this is A, B, C, and let us say D. So in triangle A, B, D, we get cos of 30 is equal to h upon x. So from here we can say that our x is equal to h upon cos of 30. So now we have two equations for x. This is 1 and this is 2. You can say from equation 1 and 2 we get 3L by 8 is equal to h upon cos of 30, and we are supposed to find out h upon L. From here we can say h upon L is equal to 3 by 8 cos of 30. We substitute the value of cos of 30, that is square root of 3 by 2. So we can say h upon L is equal to 3 by 8 root 3 multiplied by 2, and this gives us h upon L is equal to 3 root 3 divided by 60. So this is the ratio of h upon L. Ratio of h upon L. So this completes the question. Thank you.